seen quite a few people. Okay. So, here's the steps I want you to follow. You're going to make a matrix. And you're going to solve it using RREF. Okay. Second step, you're going to solve equations. You're going to get two equations. It'll make more sense when we do this, but I want you to have the steps down. For all other variables, in terms of one variable. And that's the variable z. So in other words, you're going to make an x equals something with a z in it, and a y equals something with a z in it. Okay? It's going to make more sense when you see this. Then we're going to find the positive. And when we say positive, on the number line, positive numbers are to the right of 0. So therefore, we set this greater than 0. You'll see when we do that. But all positive numbers are to the right of 0. So bless you. 0 is not a positive nor negative number. We find all the positive solutions. And we can only have integers in here. No decimals, no negatives, no fractions, no negative numbers. Because we want positive solutions, and we want whole numbers. I'm going to show you an easy way on the calculator to do that part. We're going to make a chart. With z and the equations using z. And the x equals and the y equals. And then finally, we're going to find your solutions, if any. Sometimes we get no solutions on these. We're gonna start off with one assumption first. All solutions are positive integers. So there's you can't use 0, you can't use negatives, you can't use fractions. Good. All right, I'm going to need a lot of space. So do we have all this written down? I have to erase it. I need a lot of space to do this. Okay, make sure you have that written down. And get your calculator and put the first one into RREF.
Anybody else?
I'm going to do mine up here since it's easier than doing it over there. Okay, so you're going to put the first one in there, put all your coefficients and your constants. And we recognize this to be a diophantine because we have 3 variables, but we only have 2 equations. So you can't solve for two variables and then substitute them in. I mean, sometimes it works out that you might be able to, but whenever we have three variables, two equations, we go to diophantines, this routine. Okay, so you're going to solve this using RREF. So again, pull up your matrix. Everybody remember how to do it? Out. Don't forget to say quit before you enter matrix. Second quit, get it out of there. Come back, plug this in. You're okay. I'm just putting in the thing. Alright, so now this is where we're going to start. Everybody have this matrix? Alright, I'm going to get rid of this. Everybody good with this? Reagan, did you get it all? Okay. Alright, I'm going to pull this over here now, as far as I can, until we can copy this guy down. So we put this in, we did RREF, and we got this matrix. Is that right? I don't want to make a mistake from the beginning. Okay. Alright, now, here's where your X, your Y, and your Z are. And here's your constant. So we're going to make two equations here. We're going to solve for X in terms of Z. We're going to solve for Y in terms of Z. So we're going to pull your first equation over here. It says, and I'm going to just put the coefficient even if it's a 1. 1x plus 0y minus 1z is equal to 21. I didn't put the y. We have no y variable in there, right? It should work out that we eliminate one of those variables when we do this. If it doesn't, then it's going to have no solution. Okay, so we're going to start like this. And we're going to solve this for x in terms of z. So I need this to say x equals. Over here. I need this to say x equals. Okay, so I'm going to add 1z to both sides. Does it matter if you say 21 plus z or z plus 21? No. So either way you go with that. I'm going to take the second equation. I'm just going to put a little box around this guy. I'm going to do this with the second equation. I have no x variable. I have a 1y plus 2z is equal to 10. Now I'm going to solve this for y in terms of z. When we say in terms of z, z has to be part of my equation. Y equals z blah blah blah. So I'm going to say subtract 2z. Can I say, God bless you, negative 2z minus negative 2z plus 10? Absolutely, whichever way you want to set this up. I kind of like the variable first. Okay, now we have two equations solved for x and y in terms of one variable. So now it says, after that step, we're going to find all positive solutions. So this is what we do. We take this equation, we find your positive solutions. We're going to start here, and we're going to say, okay, I want all these guys to be positive. So I'm going to say, take this thing right here, and find me the positive solutions. When we say greater than 0, we want all your positive integers. Remember, we don't want 0 in here. Okay, we're solving for z. Okay. So z has to be greater than negative 21. Now, we can't use negatives anyway, so automatically we're going to have to start right before the 0, right after the 0. But hang on to that thought for just 1 second. We're going to take this equation. We're going to do the same thing. We're going to take this little piece. We're going to solve for the positives. This is the step that everybody forgets. Not everybody, but this is the step that you're likely to not remember, like doing this part. So we're going to subtract 10. So we're going to divide by a -2. Now what happens when you divide by a negative number? You switch the sign. So z is less than 5. So if you kind of picture a number line, here's -21, here's 5, that's open. Somewhere in here are going to be my solutions. But I can't use any negative numbers, and I can't use 0. So somewhere right in here are my possible solutions. Okay, so now comes the step where we make a table. We make a chart with these two. So we're going to make this little table. We're going to put a z. You're going to put your x equal equation. You're going to put your y equal equation. And your z value is what falls on that number line in between. Those are your values of z that we want. God bless you. Remember, we only want positive integers. So I can't use a 0. I can use a 1, a 2, a 3, a 4, but I can't use a 5 because it says less than 5. So these are my possible answers. Now, all you have to do is substitute these guys in these equations and come up with these values. But we can cheat a little bit. So we go to our calculator. You can substitute them by hand if you like. Sometimes you get quite a few to substitute. We go to our calculator. Here's an easy way to do this. Go to y equals and put the first one in. I'm going to put it in as x plus 21. That's okay. Doesn't matter what variable goes in here. And then I'm going to put the second one in, also as x, -2x plus 10. And I'm going to graph. I don't care what my graph looks like. I don't want any part of my graph. I just need my table. I want those values. The easiest way to get those values without manually substituting them in is sometimes you get like 20 of these things to try. So I'm going to go to my table, and I'm going to pull up from 0, from 1 to 4. I'm going to bring 1 up to the top. Those are the values that go in my table. Just be careful which way they went. So the first one I put in, you just got to keep track of your first one. This was my first equation. This was my second equation. So my first equation gives me 22. My second equation, 8. Now, if they're fractions, I don't want them. If they're negatives, I don't want them. These just happen to work out nice. 23, 6. There's a layer for a minute. Could you guys see this? I should shut that door. 3, 24, 4, and 25, 2. And technically, we're done. We have our solutions. The only thing we have to do is put them in X, Y, Z format. So my solutions are going to look like this. I'm going to use X, Y, Z. This is my X, my Y, my Z. So I need 22, 8, 1. X, Y, Z. Okay, because we had to set this chart up a little bit different. 23, 6, 2. 24, 4, 3, and 25, 2, and 4. Okay, so here are my possible solutions. Now, sometimes this is where you can tell there's no solution. Sometimes when you pull up this chart, there won't be anything that will have a positive integer. Both of these guys, both of these pieces have to be positive integers. If one of them is a negative, we can't use that solution. So when you look at your table, that's why the calculator makes life easy. First of all, you don't have to manually plug them in. Second of all, you just have an eyeball to say, well, I don't need that one, I don't need that one. These are my solutions. Okay? A little different. It takes a few steps, and those are the steps you're going to have to remember. Again, the hardest step is this part is between here and here, right here. This is like the crux of this. Solving for your variable, setting them equal to 0. That's where these values for z come from. Okay. Good? It always sounds a little harder, but as soon as we do a couple, you'll see it flow a little bit better. And follow those steps. Those steps are going to help you. Questions at all? Okay, let's see if we can set the next one up. I wanted to do number 3. It takes a lot of space. You've got a lot of things going on in this. So give yourself enough room to do these. Whoops. Okay. Let's do number 3. They make a little bit more sense when they make a little bit more sense when they're in word problems. I know how much you love word problems, but they do make a little more sense when they're in word problems because that's where the greater than 0 thing comes from, and the whole integers. You can't have partial people, and stuff like that. So the enrollment in a number theory class consists of sophomores, juniors, and seniors. You can see your 3 variables already. If each sophomore contributes $1.25, each junior 90 cents, and each senior 50 cents, the instructor will have a fund of $25. If there are 26 students, how many of there are each? How many are there of each? So we've got 3 let statements. I'm going to put their money here. Can you come up? We have 3 variables. Can you come up with an equation? Good. I have 26 students in all. Good. So my first equation. Can we come up with another equation? Got it? Good. Very good. Equals $25. And you don't have to put the 0.00 because that's kind of understood. So now, can you come up with a third equation since there's 3 variables? No, that's all they gave us. So I have 3 variables, 2 equations. It tells me diophantines. So again, I'm going to start with my matrix. Use your decimals. Do RREF and come up with a matrix. And you're going to have to flip this matrix to fractions because they're not going to be pretty. So to go to fractions, you're going to do math. Once you're at your matrix, just do math, enter, enter. And it'll take your messy looking decimal and put it to a fraction. Try it. I want you to be able to try these and see the steps. Everybody get this? That's a 15 over 7 over there. Anybody not get this? Okay. Now, What's the next step? Anybody remember? Make the equations. Good. Very good. So we're going to take this guy, and it helps you put the things on top. X, Y, Z. Would you use the letters S, J, J? You have to use a different letter for senior. Can you use other letters? Absolutely. I tend to use X, Y, Z, but you can use whatever letters you like. So now, 1x, I like to put the coefficients just so that you see it. Minus 8/7 z equals 32/7. Don't worry about the fractions. God bless you. Okay, and what do we want to do to this? Solve it in terms of z. Good. Sometimes if you forget what to do, write both equations down side by side. Now, if I write both equations side by side, what do they both have in common? What do they both contain? Z. So sometimes when you look at both of them, it helps you say, oh yeah, I need to say x equals y equals because I got the z. So sometimes if you put them side by side, it just makes it a little bit easier. Okay. And I'm going to solve for y. Use your fractions, not those decimals. Don't round those decimals. What happens if you round those decimals, they're not exact values. You'll never come up with a solution. So you've got to use your exact values. Next step, what's the next step? Solve for the positives. We want our positive solutions. So we're going to take this piece in here, and we're going to set it greater than 0. Okay. Again, at this point, if you prefer to, I would move this over first. You have a calculator, so it really is not too bad. You could divide both sides by 8/7. You can multiply both sides by 7. Whichever way you feel like getting rid of that. It's just probably easier not to go too many crazy places. Just follow the same routine each time. And just put that in your calculator. Keep, change, flip, whatever you like to do. That'll take out your denominators, and so that should just make this a little fraction. If you like to multiply by 7 first and get rid of the fraction, that's fine. And then divide by 8. Whichever way you decide to solve that. I would just keep it simple. Use your calc. Do the same thing with this guy. Take this and do the same exact thing. Move this to the other side. What you're normally going to see is an and statement. So one of them is going to end up flipping. So again, once we divide by a negative, we are going to, God bless you, we are going to flip the sign. This takes out that denominator. And we get 10. Z is less than 10. Now, if you think about your number line, here's -4, here's +10. You don't have to make this number line. We can't use negatives anyway, so somewhere in here is what we're using. We can't use 0, and we can't use 10, right? Because it says less than 10. Agree? So we're going to take this chart, and we're going to make our chart. Z, x equals and y equals. Okay. What value should I put down here for z? 1 through 9. Good. Okay. So you're going to go to your calculator, make life easy. If not, you're going to have to substitute each one. Make your life easy. Go to your calculator. I love the calculator for this. Go to your y equals. both of these guys in your y equals. You don't care what your graph looks like. All you care about is what your table looks like. Again, just use an X. Oh, that last one. That's a Z. Sorry. Okay, so the graph we don't care about. What we care about is your table. So we're going to go to your table, and we're going to pull up from 1 on down. Now, we only want the solutions that have integers that are greater than 0. So what one do you see in this screen that would work? 3 would work. So we're going to just write this down. And we're going to scroll down and check the rest of our solutions. We just have 8 and 9 to check. And do they work? No. Yes.
Do you want us to write them all down to show you that?
No, I'm doing it now. This way you see the pattern. But when you go to do it, you don't have to do that.
Or so we just write A.
Mm-hmm. Yeah. I'm just doing that so because if I just put that there, when you go to look at your homework, you'll say, why did she just write 1?
Is it wrong would you mark it wrong if we wrote all of them down? But we
Nope.
Right. Okay.
Whichever way you prefer. But when I go through them, I kind of like to follow the full steps because when you look at it later, you say, that's odd. She wrote all the other ones down, but she didn't write these down. So this way you kind of see we only had one solution. So this guy has one solution. And remember, we need it in X, Y, Z. So put the X value first, then the Y value, then the Z value. This is the only solution. Now, if that came up like that and none of them were positive integers, we have no solution. You can go through all that work and have no solution. It's not hard. It's not that bad, but you really do have to just